Okay, good morning students. Today we have CAD lab, that is CE693. In the last CAD lab, I can remember that we have discussed about creating a grid, that is XYZ coordinate. We have created a grid. We discussed about creating beams, creating truss members. Okay, then we discussed about giving loads, etc. In the last class, I have told you, before the college got closed, I discussed that we will discuss from today, and from the next class we will discuss about creating a beam, creating a frame structure. So today we will discuss first about creating a irregular grid. Okay, in the picture you can see there is a irregular grid. First we will create that grid, then we will create a frame structure through that grid. Okay, so first we have to create that grid. Irregular grid we will create today. So first, to create irregular grid we will create all this in the stat pro. Okay, first see the grid carefully. Okay, all the dimensions are not equal, so you have to create the grid. Okay, so let us try to create a grid. Okay, so first we are going for the new project, then a plane structure. It will be a plane. You can take space also as you like. You know what is plane and space, I remember. So coming to structure one, giving a name irregular grid come frame structure. Okay, so next, add beam. We will create the frame as per add beam. Okay, so first, okay, first you see something that in this structure it is 3.2 meter, it is 4.5 meter, it is 5 meter, it is 6 meter, it is 3 meter, it is 1.5, this is 4.5, this is 5.8, and this is 4.7. now if we want to create something in the stat pro with that help, so first what we have to do, we have to change the grid. We have to change, because this is a linear grid. If you see here, edit, it is a linear grid. So here, if we again come to the picture, if we want to create that thing, we have to edit the spacing between the grid point. Now it is 3.2, it is 4.5, it is 5 meter, there is 5.8 meter, so 1.1 meter spacing we need. Total length here, from here to here, the total length is, so if we want to this is 12.7 meter all throughout, and from here to here it is 10.5 meter all throughout. So if we want to create that grid with spacing 1.1, now, so if we want to create a spacing 0.1 meter, so we need 127 grid. So if we put in the right here 127, and in the left it is 10.5, that means if it is 0.1, it is only here we can create the grid in that, if we use it the linear grid system. But if we don't want to use the linear grid system, in the stat pro we can create a irregular grid also, where we can put the values and the grid will be created. Now, very important thing, a general building structure, a general building plan is like this structure. It may be a bedroom, it may be a drawing room, it may be a store room, it may be the kitchen, okay, it may be washroom, it may be toilet, everything. So all the rooms do not have the same dimension. So if they do not have the same dimension, so a general building plan looks like this. You cannot expect a building to be always linear grid building. A building may be a irregular grid building also. So in the stat pro we can create irregular grid also. So from now we will see how to create an irregular grid. By not following this structure, we will create an irregular grid by default. So what is the procedure? First, let's see very carefully. First we will go to create. In the default grid we will go to create. Okay, so let us open a new file again. New plane structure, name is irregular grid cum frame structure. Okay, next the name is exists, so I will overwrite the name, add beam, then finish. Okay, now it will create open a GUI like that, page like that. Now from starting we will create a beam. Okay, create, change the linear to irregular, now which plane we are creating it? Generally you know that I have told you in the earlier class, a frame structure, a building is always like this. These are the columns, and this is the general frames. This is the general frame structure. So in our stat pro, if it is Y, if it is X, and if it is Z, then this frame is always created in the XZ plane. We will always try to create the frame in the XZ plane. So choosing here XZ plane, angle of plane we do not have angle of plane. Okay, name, always we have to give a name to if we want to create a new grid. This is the default grid, it has no name, but if we want to create a new grid we have to give one name of it. Okay, giving a name 1. Okay, now how to create a grid? First, in the relative grid line distance, so these are the grid line distance in the X direction and these are the grid line distance in the Z direction. Consider this is to be X, okay, and this is to be Z. So there are two type of grid connections. So X grid lines and Z grid lines will proceed. So in the X grid lines, what are the values? 3.2, 3.2, 4.5 and 5. So putting all the values, 3.2. Then we have to give on space. We are giving a space. Then again we have 4.5 and 5. So 4.5 space 5. Then in the Z coordinate we will give another values. So here it is 6, 3 and 1.5. We are creating that whole grid. We are creating from here to here. Okay, I know that here is nothing, but we will create the whole grid so as to cater for the whole structure. Okay, so it is 6, 3 and 1.5. Putting the values here, 6 from 3, 6, 3, 1.5. Okay, so irregular grid. Now select the grid. This is the default grid, but we are creating an irregular grid. So select the grid. Now the grid has been created. Now we will create the grid. Okay, so this is 0 to 3.2, then 3.2 plus 4.5, that is for 7.7. So here it is 7.7. all right, one thing, here it is 7.7. okay, I have told you always do not create one node over another. So one node is created here, I will start from here. So that is 12.7. then again from here to here, from here, here, okay. So all the nodes are placed. Now we will create the beams. Okay, first this beam to be created, we have that beam, and from here to here a beam created, and from here to here that beam is created. Now coming to the other beams members. Now other beam members. So here it is 6, we have got 6, we have got 3, we have got 1.5. Now here it is 4.5, not 3.2. So we need to move this node to from here to here and from here to here. So select the node, that node, right click, move. Okay, now how much distance it will move? What is the distance here? The distance is 3.2. If we want to see, we can see the distance is okay, the distance is 3.2. So if we want to move the node from here to here, so if you see here, this node is at here, this is 3.2 from here to here. We have to move this node to this position. So what extra distance will be? That distance is, what is the value of this distance? 4.5 minus 3.2. what is the value? Is equal to 1.1. So first we will move this point, how much distance will it will go? In x direction, positive 1.1 plus 1.1, not minus, because it is going in towards x direction, not opposite of x direction. So it will be 1.1. okay, so it has moved. Similarly this will also move. Similarly node cursor, take this value, right click, move on. So x distance will be similar distance. You have to create one node here also, so it will be 1.1. so putting 1.1 here. okay, if any nodes of the entity is being moved, follow on existing members. Do you want to this member to be split at this node? Yes. So we have got the two beams here, extra beams we have created. So it is now done. So again we will create this beam as per the requirement. Now you can see the node to node distance. The node to node distance can be specified from here. It is 4.5 now. So what is the value? 4.5 minus 3.2. Oh, it should be 1.1. Sorry man, sorry, it will be 4.3, 1.1. so it will move again 0.2. so take those two nodes here and here, right click, move, x distance 0.2. okay, yes, now it has moved. So it is, the distance is there. So that node has been created. Now coming to the next segment. Now coming to the next segment. Now coming to next segment. That segment, it is 5.8 here. it is here 5.8 and here it is also 5.8. Now we can move this node 5.8. So taking this node, now this is 3.2. So if we want to move 3.2 to 5.8, it will be, that will be from here to here, the distance is 5.2, but from here to here it is 3.2. So from here to here, that distance will be 5.8 minus 3.2 equals to 1.6. So again select the node, right click, move x direction 1.6. Okay, so we have got the node here. So again let us check the distance here. Let us check the distance between these two nodes. One node, another node. It is 4.8. We have got the value. Oh, sorry, 5.8. It should be, oh my god, it should be 2.6. Oh shit. So it should be 2.6. Again, it will move 1. So again, select the node, move x equals to 1. Okay. Yes. So now it has been created. It is 5.8. Now, one thing here, if it is 5.8, now this node is created here. We have got the 4.5 distance. So again, here has to be one node. Here has to be one node. Now we have this node here and this node here. So we are creating one node here also. Okay, we are creating one node here. Here we are creating one node. So if we are creating one node here, we need to copy this node from there to there. We will not move, because if we move that node will move. But we need to copy one node. So we will copy this node. So what will be that distance from here to here? What will be the distance? From here to here, what will be the distance? That distance will be 5.2 minus 4.5. It is 4.5, it is 5.8. So that distance will be, so that distance is equal to 5.8 minus 4.5. What will the value coming? 8 minus 5, 3. 5 minus 4, 1. So that node will copy to a distance 1.3. So again, taking this node, right click, copy the distance to be, here it is paste nodes. Where it will be placed? A distance 1.1 distance it will be placed. So okay, so that node is created. Now we will add this node and this node. So okay, it is, let us see what is the distance coming here. 5.6. Why it is 5.6? Okay, let's see. It is 5.8. It is 5.8. It is 4.5. So it is 0.3. So it is 1.3. What is the distance here? I have taken. Let us see the distance from here to here. It is 1.1. That is my mistake. So again, this node will be copied. This node will be copied to a distance. Copy, paste nodes, x value 0.2. Okay, now it is changed. Sorry, it will move. 0.2. Okay, yes. So now it has been created. Remove all the old node to the distance. So if you can see from here to here, we can see the distance is, you can see the distance is coming. Done. 5.8. So that part is created. Now here it is 4.7. So that node will move, and this node will also move 4.7. So 4.7 it will move here. Now we will now try to create this node. Now we will not need this node. we do not need this node, deleting this node we do not need, deleting this node. Okay, okay. Now so 4.7. now coming to a picture. So here it is, from here to here it is 4.7. now so here to here the distance is, if you want to see, 1.9. so how much distance it needs, how much distance we need to create here, how much distance, if it is 1.9, so it will be, so here from here to here it is 1 point, so here we need to create 4.7 minus 1.9, value is, that node, this node will be copied, so taking that node and this node, these two nodes will be moved. So right click, move. How much distance we are getting here? We are getting 2.8. so x distance 2.8 positive, because it is going towards the x direction. Okay, so that node has been moved, so it is 4.7. we are getting the value, so it is done. So that part is also done. Now coming to the central main part, that is this part. Now this is 5.8 we have got. Now from here, so here is also a node, here it is also a node, that node has been created. Now we have to create one node here. So first we need to determine, we need to create one node here and one node here for joining these two. Okay, now so here one node will be created at 3.2 and here one node will be created at 7.7. so let us try to copy these two nodes. Now we will copy these two nodes, one node and two node. So it will be copied in which direction? It will be copied in Z direction, because it is coming in Z direction. It is coming in the Z direction. So right click, copy, paste node. Z direction value will be, this value is 6 meter, this value is 6, this value is 6 meter. Okay, so we'll put that value here. So Z direction 6 meter. Okay, so all the nodes are created. Now taking this value, creating the beams from this node to this node and from this node to this node. Okay, these values are created. Now from here it will be, from here to here another node, but we do not need this node, we do not need the value of this node, we are deleting the value. Okay, so all the grid are created. So remove all the node to node distances. Now coming to general, so we can see the irregular grid has been created. That's how we can create an irregular grid. Very much important irregular grid, because now from today we are going towards creating a building structure. So this is how we create an irregular grid. Okay, so all the grid section has been created. Let us now see all the dimensions are correct or not. This is 3.2, this is 4.5, this is 5.0, this is 6, this is 3, this is 1.5. next from here to here it is 4.5, from here to here it is 4.7, from here to here it is 5.8. okay, so if we see, if we tally these two values, we can see that the result is done. The result is done. This is 3.2, this is 3.2, this is 4.5, this is 5, this is 6, this is 3, this is 1.5, this is 4.5, this is 5.8, this is 4.7. so all the values, all the nodes, all the beams are created. Okay, now we will try to create one frame structure with this irregular frame. Now how to create a frame structure? So if we want to create a frame structure, if we want to create a frame structure from this grid, first a frame structure have two things, a frame structure has two things. A frame structure has two things. What are those two things? One is this grid, which are act as a beam, and one is columns, okay, which are in the Z direction. So from each node there will be a column in the upward or the downward direction. So how to create column in the downward direction? Let's see. We will use translational repeat. Very much important. We will use translational repeat. Okay. So in which direction the column will be created? In the Y direction. So global direction Y. Consider this is a one-story building. So if this is the first story, so if this is the ground floor, consider in our picture this is the ground floor and this is the foundation. Only ground floor structure is there. Only ground floor is there, and first floor, a floor above the ground floor, is there. So we will create these two values. Okay. So what we will do? We will copy this thing into one part here and another part here, so that these two grid structure, these two floors are created. So let us check it. So translational repeat. What we will repeat? We will repeat the whole structure. Taking the whole structure, translational repeat. Y direction. Now consider this structure, this step, this floor has been created. Now we will create a floor below that and another floor below that. So number of steps 2. Default step spacing. Consider the step spacing of each step is generally it is 10 feet, that is 3.25 meter. Okay, 3.25 meters. So putting the value, default step spacing 3.25. Now always if two floors are created, we need columns to act. Now if we only repeat that, this grid will repeat, not the column will be created. But we want to join nodes to nodes. We want to join the node to node so that to create the column. So we will click on link step so as to create the column. Okay, you can see the structures have been created. This is the frame structure. Now at the bottom, so this is the first floor. If we see in the wide view, this is the first floor, this is the ground floor, and this is the first floor. But this is the foundation level. At the foundation there is no floor, so that at the last floor will be deleted. So changing the view, if we want to delete the floor here, we will change the view. We want to see it in that view so that the ground floor is clearly seen. That is the view. So this is the first floor, this is the ground floor, this is the foundation level. So we will select all the beams here. The beam cursor is selected, all the beams here we will delete. Yes, now we can see the frame structure has been created. Okay, so this is the ground floor, this is the first floor. So two floors have been created. Now you create the support. Creating support is very easy. You see, always a building is fixed at the ground level. No other support is given. So always a building is fixed. So always a fixed support will be created at. Okay, we have to add those support at all the columns at the bottom. Now we have to see the column through such view so that all the bottoms are visible. Checking the view from the minus x or minus plus x direction. So if you see, you can see all the columns are seen. Each columns are subjected to another column. So at per this line, there are other columns also. If you use this view, all the columns will be selected. If you want to see, you can check it, so that you can see that all the bottom columns are bottom nodes are selected. We will assign the nodes here, columns, supports here, assigning the support. Okay, use assign to the selected node, assign. Yes, all the supports have been given. Now let us create a beams and columns. Consider in this picture the beams are, this is consider 250, this is 350, this is beam, so consider this is the beam and this is the column. So this is beam is 250 by 350 and column is 300 by 350. So you putting the values here. So creating the geometry property, define. So rectangle, first one is YD, it is 0.35, 0.25, these are the beams, and another one is 0.35, 0.3, this is the column. Okay, so beams are that and columns are that. Now beams are, if you see in this picture, this is X direction, this is Z direction, and this is Y direction. Okay, this is X, this is Z, and this is Y direction. So all the beams are in X and Z direction and all the columns are in Y direction. So using these values, select. Now we will select all the beams and gives the and we will give the value. We will not select one by one beam and give the value. We will select all the beams together and give the value, and all the columns together and give the value. Now select beam parallel to X and select beam parallels to Z. So you can see all the beams are selected, not the columns. Beams parallel to X and Z are selected. So using the value assigned to selected beam, assign. Okay, so beams are assigned. Now coming to columns. So select beams parallels to Y. This is the Y column. So this one will be selected. Okay, always first select the thing you want to select. So Y, they are the columns. So this is the column assigned to selected beams. So this is the columns are selected. So beams are selected, columns are selected. So beams, columns both are done. Now let us see the 3D view of our building created. If we see, so you can see very clearly this is the frame structure. The beams are created, the columns are created. It looks like a very good building, a two-story building. We can see where a floor, this is the foundation level, this is the ground floor, and this is the first floor. This is the tie beam which are provided at the ground level. This is the first floor beam. Okay, so this structure is that much important. This is the first step of beam creation and the irregular grid creation. Okay, so this is for today's lecture. In the next lecture we will see how to give floor load and wall load in the beam. We will see that in the next class, in the next lecture. So practice this. I am giving you one assignment in the Stat Pro. Do that, okay, and do that. The thing is of irregular grid. Do that, and then we will discuss. Okay, in the next class. Okay, thank you, class.